So, what does it actually look like when a machine truly thinks? I'm not talking about just calculating, but really learning, creating, and even surpassing its own creators in one of the oldest, most complex games we've ever invented. We're about to dive into how AI took on and conquered what was once thought to be impossible. It all started right here. This quote says it all, doesn't it? Back in 1997, IBM's supercomputer, Deep Blue, beat the reigning world chess champion, Garry Kasparov. And that was it. That was the moment that signaled to the world that when it came to games of pure logic and calculation, the age of human dominance was officially over.
But the real question is, how did it win? Well, Deep Blue represents the first era of game-playing AI, and that era was really defined by just one thing: raw, overwhelming computational power. Yeah, you heard that right. 200 million positions every single second. See, Deep Blue wasn't thinking in the way you and I think. It was using a strategy called brute force. Basically, it was examining this colossal tree of future possibilities and just picking the best path. It didn't outthink Kasparov, it outcalculated him on a scale that no human brain could ever hope to match. To get a picture of what's happening, just imagine a game tree. The trunk is the start of the game, right? And every single branch is a possible move, which then leads to more branches of countermoves and so on. Deep Blue was built to explore as many of these branches as it physically could, way deeper and wider than any person. For chess, this was enough. But, as it turns out, a much, much bigger challenge was just around the corner. So after chess was conquered, AI researchers started looking for a new grand challenge. And they found it in a game so complex it was considered totally unsolvable by brute force: the ancient game of Go. At a glance, Go seems pretty simple. You've got black and white stones on a grid, and you're just trying to surround more territory than your opponent. But underneath that simple surface is a depth that honestly makes chess look like checkers. For decades, this game was the Mount Everest of game AI. The difference in scale here is just staggering. In chess, there are 20 possible opening moves. In Go, 361. The total number of possible board positions in the game of Go is greater than the number of atoms in the known universe. I mean, the game tree isn't just large, it's literally incomprehensible. And the reason for this comes down to something called the branching factor. It's just the average number of choices you have on any given turn. And when you have a high branching factor, you get this combinatorial explosion where the number of future possibilities just skyrockets with every single move. I mean, look at this. The numbers really tell the whole story. Chess has an average branching factor of about 35. Go's is 250. The brute force approach that worked for Deep Blue, it wouldn't even scratch the surface here. You simply cannot calculate your way out of this one. And this is the critical point. To beat Go, an AI couldn't just be a glorified calculator. It needed something that felt a lot like human intuition. It needed a gut feeling for which moves were promising and which were just dead ends, without having to check every single one. And this is where the story takes a huge turn. This is where DeepMind's AlphaGo enters the picture. And this wasn't just an upgraded Deep Blue. It was a completely new kind of artificial intelligence, a new kind of mind. See? AlphaGo wasn't programmed with human strategies. Instead, it learned through something called reinforcement learning. It basically played against itself over and over and over again, millions of games, constantly tweaking its strategy with every win or loss. It's like one person practicing Go for thousands of years without ever stopping. But here's the twist. Through all that practice, AlphaGo didn't just learn to copy the best human players. No, it developed its own completely alien style of playing. It discovered strategies and played moves that were, they were beautiful, sometimes bizarre, and totally, utterly non-human. So how in the world did it develop this artificial intuition? How did it learn to feel the game? The secret is in its really unique architecture. AlphaGo's brain really had two main parts working together. First, there was a policy network, which is kind of like a strategy expert. It looks at the board and says, okay, here are the handful of most promising moves right now. Then you have a value network, which is like a judge that can see into the future. It looks at a board position and just predicts the probability of winning from that exact spot. And by working together, these two networks made the impossible possible. The policy network slashed the massive branching factor by just ignoring all the pointless moves, and the value network let it judge a position without having to play the game all the way to the end. It was this smart, targeted search, not just brute force. But believe it or not, the story doesn't stop there. After AlphaGo famously beat the world champion Lee Sedol, the team at DeepMind pushed the whole idea even further. They created a new version. They called it AlphaGo Zero. And that word, zero, is the key to everything. Unlike the original, this version was given absolutely no human data. Not a single database of expert games to study. It started with nothing but the rules of the game, and that's it. The difference here is profound. Think about it. The first AlphaGo sort of stood on the shoulders of human masters. But AlphaGo Zero, it started in a complete void. It had to discover every single principle of the game for itself, totally free from any human bias or accepted wisdom. And the results were just mind-blowing. Starting from a state of complete ignorance, it took AlphaGo Zero just 30 hours of playing against itself to become stronger than the version that beat the world champion. After 40 days, it had surpassed every version before it, becoming arguably the strongest Go player, machine or human, that had ever existed. And because it learned without any human teachers, without our baggage, it discovered entirely new strategies. It essentially reinvented the game, finding new truths that we humans had somehow overlooked for 3,000 years. So what does this all mean? I mean, why does mastering a board game matter so much in the grand scheme of things? Well, this journey from Deep Blue all the way to AlphaGo Zero shows us something truly profound. It shows that AI can move beyond simple calculation and into a realm of genuine learning and creativity. It can generate completely new solutions to complex problems, unconstrained by conventional wisdom. And suddenly, this isn't just about games anymore. This is a blueprint for a powerful new tool for science. And that leaves us with this final, tantalizing question. The massive, complex search spaces in a game like Go, they aren't all that different from other grand challenges we face in things like medicine or material science. And what it learned from games is now being applied to solve these problems. So, if an AI can master a game this complex from scratch, what impossible problem for humanity will it solve next?